This is Algebra 2, test number 11. We got through lesson 5.3 where we're undoing squares and the square roots of things in order to solve quadratics. The first section, we're factoring these expressions. Number one, all you take out is a monomial that takes out of 3x squared plus 8x. The only thing that each of these terms has in common, 3x squared and 8x, is x. So what you're asking yourself is, what do I have to multiply x by to get 3x squared? You multiply it by 3x. And what do I have to multiply x by to get 8x? You're multiplying it by positive 8. This is all you can do as far as factoring goes for number one. Number two is nice and easy. It's a trinomial, so we make, and it's a trinomial that has an a value of 1, so that's even easier. So x times x gives you a's value. C's value is 27. 1 times 27, there's not a lot of pairs here, and 3 times 9. You have to ask yourself, which pair out of those two gets me to B's value, 12? The only one, 1 and 27, either get you to 26 or 28. 3 and 9 is going to get you to the number 6, or it's going to get you to 12. 12 is what we want, 3 and 9. This sign right here tells us they're either the same or they're different. Positive means that they are the same. And since they're both the same, this sign tells us that they're both plus. Plus 3, plus 9. Same thing for this one. Not a lot of factors of 20. This is your C value, 1 and 20, 2 and 10. 3 doesn't go into it, but 4 and 5 does. So only 3 pairs this time. The only pair out of those 3 pairs that gets you to B's value, 12, is 2 and 10. 1 and 20 gets you to 19 or 21. 4 and 5 get you to 1 or 9. So we need to use 2 and 10. This one tells us that both of the signs are the same. This one says since they're both the same, both of them are negative. Negative 2, negative 10. So if you made a mistake by putting positives there, change your answer. X minus 2 times x minus 10. Number 4, x squared minus 7x minus 30. Again, a's value is 1. Nice and neat. So x times x. More factors of 30. 1 and 30, 2 and 15, 3 and 10. 4 doesn't go into it. 5 does, though. 5 times 6. So we got 4 pairs to deal with. Which pair of those gets you to B's value, 7? 29 or 31, 13 or 17, and then the last one will get you to 1 or 11. Only 3 and 10 will get you to the number 7. So 3 and 10. This sign right here tells you that they're different signs. Remember, negative means they're different. Positive means same. Negative means different. Since they're different, this sign tells you the larger one. 10 is larger. It's negative. 3 is smaller. It's positive. Plus 3 minus 10. Now, 5 and 6 are special circumstances. 5 is a perfect trinomial. What that means is you can take the square root of the a value. The square root of 16 is 4. The square root of x squared is x. And you could take the square root of the c value. And it's actually the whole term, not just the a and the c, but the whole term with 16x squared. But the square root of 25 is 5. This sign, remember this one right here, is the one that goes in between those two, the one in front of b. So plus 5. So 4x plus 5, that whole thing is squared. That's what I meant by it being a special circumstance. 6 is a special circumstance as well because it is the difference of two perfect squares. The square root of 25x squared is 5x. 25 is 5, x squared is x. And the square root of 9 is 3. Remember, when it's the difference of two perfect squares, it's 5x plus 3 and 5x plus 3 and the same 5x minus 3. If you FOIL that back out, you get back to 25x squared minus 9. Those are two special circumstances. Perfect trinomials for number 5. The difference of two perfect squares for number 6. Number 7 says to solve by finding square roots. 4x squared is equal to 36. Remember, you work your order of operations backwards. We want to get x by itself. So before you undo x squared, you have to undo 4 times x squared. Divide by 4, do the same here. X squared is equal to 9. Undo squaring something by taking the square root of it. You do it there, do it here. The square root of 9 is both positive and negative 3. Number 8 tells you to simplify the radical expression. What is a perfect square that goes into 48? Well, your perfect squares are 2 times 2, 3 times 3, 4 times 4, 5 times 5. It is in your best interest when you start taking this test to list your perfect squares to where you can use them as a reference. 6 times 6, 7 times 7, 8 times 8, 64, 9 times 9, and 10 times 10. At least list up to those, because most of the time those are the numbers you're going to use to separate perfect squares. The square root of 48, let's just say you don't know that 16 goes into 48. Let's say that you said, well, okay, well, I think 4 goes into it. It does. 4 multiplies by 12 to give you 48. So the square root of 4 is 2 times the square root of 12. But then there's 3 questions you need to ask yourself to determine if it's completely simplified or not. The first question says, is there a perfect square that's a factor of 12? The second 2 questions involve fractions, which there's no fractions in this problem. But there is another perfect square in 12. The number 4 again, 4 times 3. Don't forget to bring this one down. That's where people make mistakes. So it's 2 times the square root of 4 is 2 times the square root of 3. And when you put these back together, 4 times the square root of 3. Again, if you recognized right away that 16 went into it, you'd have just had less work to do, because you'd have got the square root of 16 times the square root of 3, which would have given you 4 square root of 3, which is what we got eventually. Number 9, you could do 2 different ways. You can separate it into the square root of 40 over the square root of 2, or you could simply say 40 divided by 2 is the square root of 20. Now simplify that. This is usually easier for most people. The square root of 20 is the square root of 4. That's a perfect square in it, times the square root of 5. The square root of 4 is 2 times the square root of 5. No perfect factors in 5. No fractions to deal with. 2 square root of 5. If you separate it, then you'd have had the square root of 2 on the bottom. You'd have had to rationalize it by multiplying by the square root of 2 over the square root of 2. You'd have gotten the square root of 80 over 2. And then eventually you'd have gotten right back to 2 times the square root of 5. Here's one where you have to rationalize the denominator. You don't have a choice. Remember, whatever's on the bottom, radicals are not allowed on the bottom of your fractions. You multiply by that over itself. So 2 times the square root of 15 over, anytime you have the exact same radical like 15 multiplying by itself, you take that radicand, whatever's underneath there, and take it out. The only other thing you have to do right there is look at the number 2 and 15 and determine if you can reduce them. Had that said 2 over 16, you could reduce it into 1 over 8. But 2 does not go into both 2 and 15. So this is considered simplified, everybody. 2 times the square root of 15 over 15. Simplifying these, 8 times the square root of 20. You have to separate this, square root of 4, square root of 5. Don't forget to bring this down. This is where people forget. So it's 8 times the square root of 4, which is 8 times 2 times the square root of 5. 8 times 2 is 16 square root of 5. Simplify. The square root of 12 can be separated into the square root of 4 times the square root of 3. What number times itself is 4? 2 square root of 3. Negative 4 plus a negative 8. Remember, plus a negative means minus. Negative 4 minus 8. Same signs, add them up. 4 and 8 is 12, and keep the common sign negative. You need to on a number line. You're at negative 4 already, and you're subtracting 8. You're going to go this direction. That's where your negatives are. Negative times a negative is a positive. 4 and 6 is 24. 28 divided by 7, 4. 16, simplify the radical expression. Same thing you had to do when you rationalized a minute ago. Multiply by the square root of 3 over the square root of 3. Notice you cannot divide 6 by the square root of 3 and get any kind of number 2, because that's not the number 3. It is the square root of 3. Don't let that confuse you. So 6 times the square root of 3 on top over, remember, whatever's under here is what you put, 3. Now here's one of those examples I said you can simplify. 6 and 3 have a common factor. 3 does. It goes into itself once, and it goes into 6 2 times. So 2 square root of 3. You always reduce fractions. That has not changed just because we're doing radicals. '17, multiply and simplify if possible. You can multiply the square root of 21 times the square root of 7. Sure. But a shortcut to this is to notice that there is a factor in 21, 7. Now, look what I just did. I did not take a perfect square out at all. 7 nor 3. Neither one of those is a perfect square. But since we're still multiplying by the square root of 7, remember, it doesn't matter what order you multiply in. It doesn't matter. What did we say happens when you multiply by the exact same radical by itself? What do we say to do with that? Whatever that radicand is. So that would give you 7 times the square root of 3. That's a huge shortcut for those types of problems. Even though neither 7 nor 3 is a perfect square, to use the property, the multiplication property, or the product property, that helps you tremendously. Number 18 says to multiply 6 plus the square root of 3 squared. What this means is 6 plus the square root of 3 times 6 plus the square root of 3. So right here it is simply foiling. First two terms, 6 times 6, 36. Outer terms, 6 times the square root of 3 is positive 6 square root of 3. Inner terms, square root of 3 times 6, positive 6 square root of 3. Last terms, square root of 3 times the square root of 3. Remember, anytime it's the same radical by itself, it's simply positive 3. Combine your like terms. 36 can be combined with 3 to get 39. 6 plus the square root of 3, times the square root of 3 can be combined with 6 times the square root of 3. 6 plus 6 is 12 times the square root of 3. Foil this one. The square root of 3 times the square root of 3. First terms, 3. Outer terms, the square root of 3 times a negative square root of 7. Negative square root of 21. Inner terms, the square root of 7 times the square root of 3. Positive square root of 21. Last terms, the square root of 7 times a negative square root of 7. Negative 7. Combine your like terms, 3 and negative 7, negative 4. Negative 21 and positive 21, square root of 21, cancel out. That would be 0, negative 4. Then number 20, simplify by combining like terms. This negative has to be distributed. Negative times a negative, positive 4y. Negative times a positive, negative 8. Plus 8y. Combine your like terms at this point. 4y and 8y, 12y minus 8. Can't put those two together, not like terms. 21, variables on both sides. Collect them all. 5y, negative 8y. That's smaller. Bring that over by adding 8y. If you add it to the right, add it to the left. 5y plus 8y is 13y. Plus 10 is equal to 17. Undo plus 10 by subtracting it. Subtract it here. 17 minus 10 is 7. 13y equals 7. Undo 13 times something by dividing by 13 on both sides. Y is 7 over 13. Number 22 says negative 9y minus 11 equals 2 times y minus 4. Remember, before you try to undo anything, you have to simplify. 2 distributes to y. and to negative 4. So we have negative 9y minus 11 equals 2y minus 8. You have variables on both sides. Bring your smaller y over to your larger one. Collect your variables. Negative 9y is smaller than 2y. So add 9y to the left. If you do that, add it to the right. 2y plus 9y is 11y. You still have negative 8 on the right. You still have negative 11. Don't lose it on the left. You brought your y's to the right side. Bring your constant terms, in this case negative 8, to the left side. Undo negative 8 by adding it. If you add it to the right, add it to the left. Negative 8 plus negative 11 plus 8, opposite signs. Subtract them. 11 minus 8 is 3. And 11 is the higher absolute value. It's negative, so it's negative 3 is equal to 11y. Undo 11 times something by dividing by it. Do the same to the left. Negative 3 divided by 11 is simply negative 3 over 11. There's no numbers that go into both of those. Y equals negative 3 over 11. '23 is a lot of people's favorite problem from the last month and a half or so. You have to distribute 6 times x minus 0.8. 6 times x is 6x. 6 times negative 0.8 is negative 4.8. You also got to distribute negative 0.2 times 5x is negative 1x, and negative 0.2 times negative 4 is positive 0.8 is equal to negative 2. Again, before we try to bring anything across, we got to combine our like terms. 6x and negative x is 5x, and negative 4.8 and positive 0.8 is negative 4. So 5x minus 4 is negative 2. Not simpler of a problem now. Undo minus 4 by adding it to both sides. 5x is equal to 2. Undo 5 times something by dividing it on both sides. X is equal to 2 over 5. 1 is equal to x over 8 minus 5. Add 5 to both sides. X over 8 is equal to 6. Notice we just undid minus 5 by adding it to both sides. X over 8 means x divided by 8. You cancel that out by multiplying both sides by 8. X is 48. And that's just working the problem without showing every arithmetic step. That is showing every solution step there. 25 says 7 plus 8n is equal to 31. It's a nice simple two-step equation. Subtract 7 on both sides. 8n is equal to, when you subtract 7, you get 24. Divide by 8 on both sides. N is equal to 3. You have to distribute 4 times y is 4y. 4 times 7 is 28. Equals 44. Subtract 28 on both sides. 4y is equal to 14 minus 8 is 6. And then 4 minus 14 minus 8 is 6. And then 3 minus 2 is 1. So 4y is equal to 16. Divide by 4 on both sides, and y is 4. 27 says 4f of x equals 2x minus 4. Find f of negative 1. That just means in place of x, we're subbing in negative 1. So 4f of negative 1 equals 2 times negative 1 minus 4. Order of operations says do 2 times negative 1 first, negative 2 minus 4. Negative 2 minus 4 is negative 6. So for f of negative 1 equals negative 6. 28 says to graph this equation. It's in a nice, neat form. Y equals mx plus b. Remember, the sign in front of it goes with it. So you're beginning on your y-axis at your y-intercept. Remember, this one here is your y-axis, the one going up and down. You're beginning at negative 1, 2, 3. So we're going to begin at that point right there. Your slope is how you move is 1 over 2. Remember, it's rise over run. It tells you to go positive 1 means go up 1, either up or down. Positive means up. Over run tells you to go to the right 2 times since it's positive. So up 1 and to the right 2 times from the point we already drew. You have 2 points. You draw yourself a line right through both of them. That's what your graph should look like. 29 tells you to find the slope. Slope formula, m equals x sub, not x, y's on top, y sub 2 minus y sub 1. Remember the difference of y over x sub 2 minus x sub 1. If you have to label them, this is x and this is y. X and y, remember it's alphabetical. This is 0.1, this is 0.2. So m is y sub 2 is this one, 2, minus y sub 1 is this one, minus a negative 7 over x sub 2 is this one, negative 9, minus x sub 1, a negative 11. 2 minus a negative 7 means plus 7, which gives you 9. Negative 9 minus a negative 11 means plus 11. Negative 9 plus 11 is positive 2. Your slope then is positive 9 over 2. And number 30 says evaluate the expression for the given value of the variable. Sub this in place of x. We did it a little while ago when we did the function form. So negative 2 times negative 2 instead of x squared plus negative 2 plus 3. Order of operations says you do exponents first. Negative 2 squared is positive 4. That's still multiplying by negative 2. Plus a negative 2 means minus 2 plus 3. We multiply next. Negative 2 times 4 is negative 8 minus 2 plus 3. Negative 8 minus 2 is negative 10. Negative 10 plus 3 is negative 7.